Hi and welcome back, guys. Now we're going to do a quick review over balanced forces and unbalanced forces. You've got your handout. You see here it's got a dotted line right up in the middle. You're going to take your scissors and cut up right on that line. So you have two separate rectangles. And before we begin, remember that force can be a push or pull on an object. Also remember that we measure that push or pull, or what we call force, in newtons, and we represent that with the capital letter N, as in Nancy. When talking about forces, remember you've got balanced forces and unbalanced forces. That's why we've got two different photos or two different pictures here. So we're going to go ahead and take the unbalanced forces one and set it to the side, and we're going to focus on balanced forces. Now when we're talking about forces, again we're talking about balanced forces and unbalanced forces. Our balanced forces we're going to represent with our blue and red color pencils, so make sure you have blue and red. And then your unbalanced forces we're going to use our green and yellow. Now take your red and blue color pencils and color just as I have here. Remember, neatness counts, so give me your best scholarly work. Remember when we're talking about balanced forces have a net force that equals to 0. Now your copy shows it looks like an O and the letter N for newtons, 0 newtons. Draw a line through that 0 whenever you are in science. Remember, that's how we write our zeros, so we know it's not an O. Also remember, balanced forces are forces that do not cause a change in the motion of a moving object. What that means is if the object is not moving, if it's stopped, it will stay stopped. If the object is moving in a direction, it'll continue moving. And number 3 specifies again what we just said. It will not make a motionless. Motionless means it is not moving without motion. It will not make a motionless object move. Take a couple of moments and draw the example I have here. There's a square on a surface. If you notice, there is forces being pushed up from the surface. This could be a table, it could be the floor, and this is forces pushing down. That is the box or square being placed on the table. Just example, think about a big refrigerator box. When the delivery people bring it in, they set it on the floor. So you've got pressure coming from the box onto the floor and the floor pushing up on the box. How do we calculate that? Pretty simple. We take the given 10 newtons, that's 10 newtons of pressure being pushed from the box and the 10 newtons of pressure being pushed from the floor, and we subtract them. So you now have 10 newtons minus 10 newtons equals 0 newtons. That makes it balanced. Notice quickly how balanced and unbalanced are spelled. They're very similar. The only difference is the UN in unbalanced. That makes them direct opposites, that UN. Therefore, unbalanced forces are just exactly the opposite of balanced forces. So in this case, unbalanced forces have a net force that does not equal 0 newtons. Again, put the little line through it so you know it's a 0. Unbalanced forces can cause a change in the motion of an object. What that means is if it's in motion, if it's moving, it could cause it to stop. Or if it's stopped, it's just sitting there, it could start to move. Unbalanced forces also cause a change in the object's speed and or direction. Now, we haven't talked about speed. Speed is how fast the object is moving or being pushed or pulled, and it can also change the direction. It could be going forward and then it changes to back. It could be going left and then it changes to right. It just depends on which side has the most force. Let's look at the example listed here. You've got pressure on that box coming from the right. It's registering 15 newtons of pressure. And then you've got 10 newtons coming from the left, or I should say being pushed to the left, and 15 newtons being pushed from the right. So you've got some give and take, kind of like tug of war. Now, we said before we subtract the two, so we do the exact same thing. We subtract the 15 newtons minus or subtract 10 newtons, and that gives us 5 newtons. So this is telling us that this is going to move to the right because there's more pressure, more force being pushed to move it to the right. Now take those two sheets. Ms. Rhines, Ms. Vasquez, and Ms. Tristan Aldama will tell you what pages in your journal these will be glued on. Balanced forces will be glued on the left, and the unbalanced forces will be glued on the right side. Now take those two sheets. Ms. Rhines, Ms. Vasquez, and Ms. Tristan Aldama will tell you what pages in your journal to glue these on. Balanced forces will be glued on the right, and on the left. Balanced forces will be glued on the left. Now take those two sheets. Ms. Rhines, Ms. Vasquez, and Ms. Tristan Aldama will tell you what pages in your journal to glue these on. Balanced forces, that's the red and blue one. That will be glued on the left side. Unbalanced forces will be glued over on the right side. Now, if you take the unbalanced or the balanced forces, that's our red and blue sheet, you see this little line right here across the top. Fold it or crease it on that line. Fold it forward towards the colored letters. That's where your glue will go. If you're using bottled glue, we just need 5 drops of glue. Two, 3, 4, and 5. And then you just press that flap back down to glue it down. Now, if you're using glue stick, you can put glue stick across the top. You're now on unbalanced forces. Again, this is on the right side. Unbalanced forces, if you notice, there's no flap on top. Your flap is down on the bottom. So you're going to fold just the same way we did towards the colored space. Put your glue. 1, 2, 3, 4, and 5. And push that down so that it's glued into your journal. So you have balanced forces here and unbalanced forces here. Now let's recap. For balanced forces, that's our red and blue page, we can say, let's lift that flap. Balanced forces are when two forces on an object produce no change in the motion of an object They also have a net force of 0 newtons. When two forces on an object produce no change in the motion of an object, the net force is equal to 0 newtons. For unbalanced forces, again on the right side, that's our yellow and green. I'm gonna have to turn my journal a little bit sideways because I can't write straight up and down. We can say when two forces produce a change in the motion of an object. Remember, that could mean stop and go or right to left. The net force is greater than, we should remember that from math, see, I misspelled that, even teachers make mistakes, greater than 0 newtons. So when two forces produce a change in the motion of an object, that means stop and go, right to left, then that net force is greater than 0 newtons. Now let's take our unbalanced forces. Take that yellow and green color pencil and color as I have here. Take a couple of moments.